Right, welcome back to a brand new video, guys. I'm very excited for this one because we're going to be going back to Zig. Now, first video I made with Zig, I just covered a Hello World program, and it was very confusing because they had this input-output interface which was recently added to the language, and it has its reasons, but it's just very confusing if you're a beginner. So, I've seen a lot of people mention Ziglings, and I've never heard of it before. I've recently discovered there's also Rustlings, where it's almost a project where you can, get familiar with the language through a series of exercises which you can complete. It's effectively fixing tiny broken programs. So, and it does explain that briefly here. Okay, so we're going to be doing this project. We're going to be taking on some of the exercises. Now, we're not going to get all of them done. Of course, we're not, because we're literally just starting on this, and it would probably take a whole afternoon to get this complete. I don't know. The programs could be quite simple, but we'll find out now. All right. So the first thing we're going to do then is git clone. So we're going to effectively copy these files and folders in this repository then, so that we can use the exercises ourselves. So codeberg.org and Ziglings, and then exercises .git, and then we're going to put that in a folder called Ziglings. So once that's downloaded, we're going to go into our Ziglings folder, and we should have everything here, which we do. So that's fantastic, okay? Now, I don't think I have the latest version of Zig installed, so what I'm going to do is just Zig run all of these exercises. Probably a better way to do this, I don't know. So let's see if we can work our way through these exercises then. I think it might be a better way to learn, because you're actually learning through programming, but also through fixing programs that are already done for you. So you see the familiarity, how the code is structured, and then you're just effectively doing your little bit and figuring things out and problem solving, which just seems quite fun, to be fair. This is a good way to learn. I'm happy with this. So let's take a little look at it. Now, we don't need that browser anymore, so I'm just going to ignore that. We're going to cd into exercises, and you can see there are a lot of programs here. So there's over 100, so there's a lot of programs. We're probably going to make it up to like 10 or 15 today, wouldn't surprise me. But we're going to see if we can get through as many as we can in this short time. I might enjoy it and carry on, but that leaves more rooms for future videos if you guys want me to work through this with you. So first thing we're going to do then is go into 001, and we're going to fix these programs. Now, first one should be pretty straightforward because it's a Hello World program, but then again, I did have issues with the last Hello World program, so who knows, maybe we'll struggle with this one already. I'm going to read through the comments, and we're just going to work through it together. So, right. Oh no, this is supposed to print Hello World, but it needs your help. Zig functions are private by default, but the main function must be public. A function is made public with a pub statement like so. So you can see public, which is a keyword, function keyword, the name of the function, and what it's returning, or the type it's returning. So this is the example, and we need to fix this bit of code now. So perhaps knowing this will help solve the errors we're getting with this little program. So I'll talk through what I do understand as we go along, and maybe I'll get corrected along the way. Const is just something that cannot be changed, so it's a variable that we cannot change. std is the name of the constant then. And we are importing, now this is interesting, this is a built-in function in the Zig language, so it's effectively calling import, and we're importing the standard library into this variable so that we can use that code which is predefined in our program. What we need to add then is the pub statement. So if I just add pub, and that should be it for this one. Now, something that I should explain, which is probably more suited to the people who watched the previous video. I believe, again, correct me in the comments if I'm wrong, there's 3 files in Zig. There's standard error, standard input, standard output. Now, we are writing to standard error, okay? Which is why we are not using the IO interface, which we got so confused with last time. So that's what I think is happening here, okay? So if I just simply do zig run 001, should work, and it does work. Fantastic, okay? So I'm going to clear that, and we're just going to go on with exercise 2. So if I do this, perfect, right. Oops, this program is supposed to print a line like our Hello World example, but we forgot how to import the Zig standard library. The import function is built into Zig. It returns a value which represents the imported code. It's a good idea to store the import as a constant value. Okay, so we don't have to use a constant. We could use a variable with the same name as the input. Oh wait, no. Am I wrong in saying that? We'll try that out now. we'll give that a little bit. We'll give that a go. I don't know if it has to be const. Right, so the example then is given to us. So all we have to do is something similar to what we've seen in the last one. Now I'm curious if I just did var std. I wonder if this would compile. I don't know if it would. So if I do that, it doesn't run, and that is because it must be a const. Okay, so let's make that change then. I mean, that makes sense. I kind of had a feeling that would happen, but just wanted to experiment to play around with it. Oops. Okay, so now if I do this, should work. And it does. Fantastic. So that's the first two programs done. Okay. Now the next one we're going to look at, let's have a little look what this is going to be about. So assignment. Okay, so it's going to be to do with variables. It seems we got a little carried away making everything const unsigned 8. So const means the values can't change. It's constant. It's like the speed of light. It's like pi. It's a value that cannot be changed. Okay. Now U just means unsigned. So unsigned types that are unsigned and cannot store negative values. So for those of you who don't know, who haven't studied computer science or computing, you have signed integers, which are your positive and negative integers, and you have your unsigned integers, which are just your positive integers then, okay? 8 then is, it means the type is 8 bits in size, okay? So example then, foo cannot be changed, it's constant, and bar can be changed, it's a variable. Okay, so we have const foo unsigned 8-bit, which is 20, and we have var, which is called bar, which is an unsigned 8-bit integer, which is also 20. Okay. Example for this then, so foo cannot be negative and can hold 0 to 255, because that's unsigned, and then this can be from minus 128 all the way up to 127, then positive. Foo can hold up to 8 bits, so that's 0 to 255, and bar can hold 16 bits, which is 0 to 65,535. Okay, so it's pretty straightforward. It makes sense. You can go all the way up to 64-bit then, okay, which can hold very, very, very large numbers. So that's that. So what we need to do then is fix this program so the types can hold the desired value. So we have a const, which is n, which shouldn't be a const because we are changing it just after, so we'll change that to a var. So that should be fine now. We have const, which is pi, which is unsigned 8-bit, which I believe is too small. 8 bits, so what do we need? We can do 16 bits, we'll just do 16 for this then, so it can stay unsigned, but we have to change that to 16-bit. Negative 11, so that is unsigned, that needs to be signed. Signed is just I8, okay, so that should be fine. And I think that is everything, so let's give this a little go now. And run that, and it should run just fine if we've done it right. And we haven't done it right. Okay, so type unsigned 16 cannot represent an integer value. Okay, let's have a little look at this then. Pi, right, so we have pi, which is 3, okay, right, so is that right? Is it too small? I think it might be. Let's try it one more time. Fingers crossed, and it works. Hallelujah. Right, we got that one working, so that's good. What we need to do now then is task 4. Let's have a look. Arrays, okay. I haven't done anything with arrays in Zig. I haven't done even signed or unsigned integers, so it's good to get familiar with this. I could jump a little bit ahead, I suppose, but I think that takes away from the fun of doing this sort of project in the first place. So let's learn some array basics then. So arrays are declared with var, foo, and then we specify the amount of numbers that are going to make up the array and whatever type it is. Now I'm curious about this because it says var foo, which is going to contain 3 unsigned 32-bit integers, but I'm curious as to why they repeat it again here. So someone could explain that. That'd be interesting. When Zig can infer the size of the array, you can use underscore for the size. So you can also let Zig infer the type of the value. So the declaration is much less verbose. Okay. So var foo underscore saying we don't know how many, or we'll allow Zig to determine how many there are in our array of unsigned 32-bit integers. So get values of an array using index, which is standard across most programming languages, so that makes sense. Set values of an array using array index. So foo 2 equals 16. So sorry, I'm a bit lost as to what the difference is between these two. So get values of an array using array index notation. Set values. All right, okay, so this is just us retrieving the value, and this is us setting the value, right? Okay, that makes sense. Right, so what do we need to do then? So get the length of an array using foo.len. Okay, see, things like that are just quite nice to have in a programming language. Again, where C falls short, I suppose. It's not where C falls short, but it can become frustrating for C users then. Right, so we have a public function. Problem 1, this const is going to cause a problem later. Can you see what it is? Okay, so I'm guessing we're going to change this, which we do, changes it, so that's going to be changed to a var. Because, right, so some primes, so the first number's wrong, so 1 is not a prime number, so we change that to 2, and then we go down here, so const first, some primes. Individual values can also be accessed with the square brackets notation, or the brace notation, the brackets notation, sorry. Example, this line stores the first prime in first. Problem 2 then, looks like we need to complete this expression to set the fourth, so that'll be 3. And then down here then we change that to len, and I think that should be right. So again, let's give that a go. Oops. Come on. There we go. That should work. Perfect. So that is spot on. So we got our first 4 programs running. Let's go on to program number 5. Let's give this a go. Arrays 2. Okay, we're still on arrays. Great. Zig has one array operator. You can use plus plus to concatenate 2 arrays. I don't think I've seen that before. We use plus plus to concatenate 2 arrays. So let's take a little look at that then. So const A 1 2, const B 3 4, and then you can use A plus plus B plus plus, and then adding another number on the end. So this should be a pretty straightforward one. So problem number 1 then is just concatenating the 2 arrays. So that will be li plus plus et. Oh, sorry. And then down here, this is interesting. So please set the array using repetition. So it should result in 1001, 1001, 1001. How long should the bit pattern be? How long should the bit pattern be? Okay, so I think what we have to do then is create an array, which is going to be, we'll let that infer, we'll say unsigned 8, and then we'll do, I don't know if I'm doing this right, 1 0 1 0 1, and then down here if we set this to 12, it's going to repeat the length from the bit pattern that we provide. Again, let's give that a go. Right, hopefully this will work, and it works. Okay, that's cool. I didn't know, I don't know what SIMB, I think that's is that assembly? I think I remember seeing that in the podcast with it's a type of assembly language, I think. I'm sure I've seen, I might be getting confused. SIMD, I believe I've seen FFmpeg talk about it on the Left Streamer podcast. So that's that's what I know of that. But it says don't worry about it. We'll probably come on to that later, I imagine. And then this is just printing that out then. So const bit pattern. So for bit pattern, not sure about this. This is just the one that it's going to be incrementing. Looks that way. This is weird as well. I mean, I quite like it because it probably makes things a bit more readable. It's just a bit more typey then, isn't it? But yeah, no, that seems pretty cool though. Okay, that makes sense. Let's move on to number 6. What are we on to now? Strings, okay. Right, now that we've learned about arrays, we can talk about strings. So we've already seen Zig string literals, so hello world. Zig stores strings as an array of bytes, very similar to C. Const foo hello can be the same, or is almost the same as an array with hello in it, or spelled out in terms of letters. We'll see what Zig strings really are in exercise 77. Pardon me. Notice how individual characters use single quotes and strings use double quotes. These are not interchangeable. Okay, Andrew Kelly must be, or whoever created Ziglings must be a Bowie fan. So let's have a little look at this then. So we want to, problem 1 is use the, use square bracket syntax to get the letter D from our string. So that is the 1, 2, 3, 4, 5. So it's the 5th one, which is going to be 4. So that should be that. Here then we just adding these together, so concatenating them two. And is that it? I think it is. So let's take a little look. Oh wait, hang on. We have to add a space here as well. So if I do this, okay, I don't know what's happening here. Right, we have to add a space. So wow, I really don't know what's going on there. My keyboard is just jumping around. Right, so we'll add the space in. I think that one's pretty much done then. So if I, space, and then we'll do plus plus, and I think that is it. So let's give that a go. Zig run 6. There we are, perfect. So is that going to work? It is, great. Okay, so yeah, we got the, so we know how to look for a specific element in a string. We also know how to concatenate two strings together that are stored in variables. And we know that we need to use, this is basic programming stuff. Up to now, anyway, this seems pretty straightforward. So let's go to number 7. Again, we're still on strings. I'm sure there's a lot we can look at there. Here's a fun one. Zig has multi-line strings. So to make a multi-line string, put 2 backslashes at the beginning, line just to, like a code comment with backslashes instead. Okay, so it's just the opposite of just figure out what my backslashes are. There we are. It's just the opposite of comments then. So if we just do this, and then we'll do that again, and I think, if I'm right, that's how it'll work. So let's give that a go. So far, right, I kind of wish that I'd done this previously. Like, I don't know why I waited. Like, I don't know why I done it the way I did before. But again, I didn't know about this stuff. That's fantastic. Okay, right, that makes sense. I just wish that, you know, this was more, well, more known for beginners, because again, it's something that I didn't even think about. So we've got a quiz now. So hopefully I can pass this little test. So quiz time. Let's see if you can fix this whole program. You'll have to think about it, this one a bit. Let the compiler tell you what's wrong. Start at the top. So we have letters here. usize is an unsigned integer type for sizes. The exact size of usize depends on the target CPU. So is that similar to size t then? I'm not sure. In C. We could have used U8 here, but usize is the idiomatic type used for array indexing. So that seems similar to C then, where you use size t when dealing with strings and such like that. Right, okay, so note, when you want to declare memory, an array in this case, without putting anything in it, you can set it to undefined. Okay, that's pretty straightforward, so it's effectively setting it to null then. Or just declaring a variable without even assigning a value to it, so that's pretty straightforward. The following lines attempt to put zig into the lang array. Okay, right, so we've got letters here, which is our string at the top, which we're going to put in. So let's first of all change this to zig. So that's our letters string. And the first thing we're going to do is put into lang 0, which is our array, which we haven't defined yet, which holds three values, which is going to be zig. So we're going to do lang 0 letters x, which we need to change to 0. And then we're going to do x is going to be 1 then. And we're going to put 1 here, oops, 1 here. And, oh wait, x, oh wait, sorry. No. Wait, no, we can still do that though, can we? Wait, did that matter? I don't know where I just changed now. Yeah, no, so we can, right, so if we change that to 1, then we change that to 1, and then we'll change this to 2, and we'll change this to x, and we can change that to x. There's a problem in here as well, so do I have to change that to 0? Yeah, change that to 0, and then I'll change, no, that can stay x, but it has to change the var because we're changing that later on. Let's give that a go. I don't know if that'll work, but it's a good starting point. So will we pass the quiz, moment of truth, and there's an error. Expected a comma. Did I do that? Why did I expect a comma? Ah, is that it? Did I do that? Okay, let's try that again. Perfect, there we are. I think I've done that right. I don't know if I changed anything. I think there's a million and one ways in which you can do a different task, so it's very possible that I've probably done that the wrong way, but who knows. Okay, right, we're going to do nvim 009 now, so let's do that. We're on if statements. What did I do there? Did I? Right, I put zig, right, okay. There we go. Right, okay, we're on to if statements now. Again, something I haven't done in Zig before, so let's see if we can get it. Again, I'm pretty certain this is going to be pretty straightforward. So now we get into the fun stuff, starting with the if statement. If something's true, then we're going to do this, otherwise we're going to do something else. So that's basic programming, okay? We can either do this or we can do this, conditional branch it. Makes sense. Zig has the usual comparison operators, such as A equals B, or A is less than B, or A is greater than B, or A is not equal to B. The important thing about Zig's if is that it only accepts Boolean values. It won't coerce numbers or other types of data to be true or false. Okay, right, so please fix this condition. So do I have to just change this to this? It only accepts Boolean values, so let's try that. So if it's true, we'll print, oh wait, no, sorry, no. I just had a, right, so if foo is equal to 42, 42, then we'll print that. If not, then we're gonna do that, okay. I don't know what I was gonna do there. Right, for some reason it's lagging a bit. Give it a sec. There we go. Change that to 9, tab, and run that. Don't know why it's a bit of a delay on my keyboard. There we go. That should work. Right, yeah, foo is 42, so that works. Okay, so that was pretty straightforward again. So now we're on 10. We're on our first double digits. Let's see if we can get if two working. So if statements are also valid expressions. So const foo u8 if a2 else 3. So we can do single line if statements, which is very similar to C. Something that I haven't played around with in C much, to be honest, but I know you can use a semicolon and a question mark to do a similar thing. I don't even think you have to use that. I think you can do it very similar to the way Zig has done it here. So if, what are we going to do? If discount, so please use an if statement to, please use an if else expression to set price. If discount is true, the price should be, right, so if discount, oops, don't know what's happening here. If discount 17, else 20. I think that should be the case. Again, pretty straightforward, I hope. Did that work? And it did. Fantastic. Okay. So far, I'll be honest, I'm really enjoying Ziglings. I think I could, if programming was this easy all the time, you know, in terms of learning the language, like, I quite like this personally. I'm sure most people do, and I get why people actually recommended it in the first place, because I've seen that people said that Ziglings is much better than Rustlings. Again, I've no experience with Rust, so I wouldn't know, but yeah, I quite get enjoyment out of this myself, so that's pretty cool. Right, so Zig, while statements create a loop that runs while the condition is true, this runs once at most. So while condition equals false, remember that the condition must be a Boolean value. So again, similar to any other sort of language here, A equals B, so on. Okay, right. So please use the condition. So while n, right, so please use a condition that is true until n reaches 1000. So while n is not equal to 1200, 1024, print. So that should work now, I hope. Yeah, so it's pretty cool. Okay, there we are. So that's another one done. Let's go to 12 now. So Zig, while statements can have an optional continuous expression, which runs every time the while loop continues, either at the end of the loop or when an explicit continue is invoked. We'll try those out next. So while condition, continue expression. So it looks something like this. So while foo is less than 10, we're going to do foo plus equals to 2. So it's just incrementing the value then, is it? Every time we run the loop. Do something with even numbers less than 10. Okay, I'm going to have to see this to actually understand what's going on. What's it saying? Right, so we're saying while n is less than 1000, we're going to continue. Please set the continue expression so that we get the desired results in the print output. Continue. What's happening here? So what's n? While n is less than 1000, we want to continue. We want the result to be 1024. I literally don't, I can't make sense of this at all. Right, Zig while statements can have an optional continue expression which runs every time the while loop continues, either at the end of the loop or when an explicit continue is invoked. Okay, this is the first one that's throwing me a little bit. I've never seen this before, so it's very unusual. So if we had, right, I'll look at this example because maybe it'll make more sense. So if foo is less than 10, foo is less than 10 plus equals to 2. But how are we going to get, so while n is less than, do we just do plus equals n? Is that right? Did that do it? No. Okay, this is throwing me off a bit. So n is equal to 2. We're saying while n is less than, continue. So we want the output of n to be 1024. We're saying whilst it's less than 1000, keep on doing something. Is it n times 2? Oops. I'm just guessing now. Cannot continue with operand. Have I typed it in wrong? Okay, that's throwing me off now. What have I done wrong? Right, let's have a little look on Google. I think that's probably the next best step. So continue statements in Zig. Oh, do you just? Oh, right. I've used continue. Right. Right. Okay. Is this right then? N. Right. Let's try that. Okay. Okay. Maybe it was the plus equals. Plus equals. Oh, okay, that's not right, is it? Surely. I don't know what I'm doing. Right, okay. What am I doing wrong? I don't know what I'm doing. Clearly, I have no clue. So, why can't I see the logic in this? N. I need a rubber duck to talk to, honestly. I'm going crazy. So, while n is less than 1000, please set the continue expression so that we get the desired results in the print statement below. As in the last exercise, we want this to result in n equals to 1024. So we're saying while n is less than 1000, so couldn't I just, I think I have to change, if that was the case, I'd imagine that I'd have to change it to this. Can I just do that? Or is that cheating? I don't know if... Yeah. Is that what I have to do? Right, okay, so that one's done then. So let's just get back to the challenges and we're going to go to exercises. We're going to go to 13. Now we're probably going to work up to 15 on this video just because I don't want to do too much because I don't know how long this video is going to be. I think it's already nearly 30 minutes. So let's get a couple more done and we'll call it there for this episode. So the last two exercises then were functionally identical. Continue expressions really show their utility when used with continue. So while condition, continue doing something. If other condition, then continue. The continue expression executes every single time the loop restarts, even when a continue statement skips the rest of the loop body. So we're saying while n is less than or equal to 20, n, we're going to increment n by 1. If n, okay, right, are we going to say like what are we going to do? So the modulo, or the percent symbol is the modular symbol or operator, and it returns the remainder after division. So we need to do something. So effectively, if it's divisible by 3, then we want to do something. What's it want us to do? I want to print every number between 1 and 20 that is not divisible by 3 or 5. So we just add continue, is it? Do I just add continue? I don't know if that's it. Okay, oops. That could be it. Let's give it a go. Yeah, perfect. Okay, so it's pretty straightforward. That was an easy one. Let's go on to the next one now. So we're on 14. We're still on while loop. So you can force a loop to exit immediately with a break statement. So continue expressions do not execute when a while loop stops because of a break. Right, okay, that makes sense. So n is equal to 1. We're saying while true, we're adding n to 1. Please fix this so the print statement below gives the desired output. We want 4. So while n is not equal... oh wait, are we not meant to change that? So if n is equal to 4, then we want to break. Is that right? Oops. I think that should be right. So let's do this. 14. And yes, we got it right. Okay, these are pretty straightforward. I think, in all honesty, if I had more time, I could probably get all of these done this afternoon if they continue being this easy, which they most certainly probably do not. Great statement there. Behold, the for loop. The for loops let you execute code for each element of an array. So for items, right, okay. Okay, this makes sense. So it's just a for loop, but I've never seen this syntax before. I don't know where they got the inspiration for this. So for story, the for story, can we just do item, do something with item? What do we refer to? Can I just say n? So story HHSNH. Does it matter what I call this variable? So for story, and I've got n, if scene is h. Ah, wait, right, sorry, right, scene. Yeah, oh, I think that's right. Let's give that a go. Do 15, tab, run. That should work. Is that right? That doesn't look right. It should be printing out. Oh, no, I think it is. Happy, happy, sad, neutral, happy. Yeah, I think that's right. So it looped over each of them and it printed a smiley face, sad face, or neutral face based on that. That seems pretty straightforward. So we're done with that. Okay, we'll do one more because I feel like these are pretty straightforward. So we'll go to 16. Oops. Right, let's have a look. So for loops also let you use the index of the iteration, a number that counts up with each iteration to access the index of iteration. So, okay, right, so we can have our items, which is the list itself, item, which is the particular item in the items, and then we have index, which is, so for loops also let you use the index of the iteration. okay, this is a bit. So do I do bits? Bit. Does that matter? I don't know if it does. Hang on. So if I leave that there a sec. So, right, for items, right, 0. Okay, so we'll set the first one to 0, is it? Is that right? Or value. And then we'll say index. And what is that doing? So it is, this is a built-in function, just like import. We'll learn about these in a later exercise. See, those are the exercises that I'm most looking forward to, are the ones that are completely different, the ones that I wouldn't know that are very relevant to Zig, but it's good that I'm learning the basics from this. So, right, so we have bits, we have value, value, which is 0, and then we have bit and we have index. So the index of the iteration, a number that counts up with each iteration. Okay, so bit, index, what is this doing? Value, place value. Is that right? I don't know if that is right. Let's give it a go. Yeah, so something to do with I, so incast I, which is our index, I'm assuming. So let's have a little look at that. So if we go down here, if I do that, I think I'm being lazy, but yeah, that's not going to be right. Oh, what am I doing? Right, okay. Right, so for loops also let you use the index of the iteration, a number that counts up with each iteration. To access the index of iteration, specify a second condition as well as a second capture value. A second condition, which is 0 in this case, so I'm guessing it says, is that saying start from the 0 index, and as a capture value. You can name item and index anything you want. I is a popular shortening for index. So bits is our list. Value is our 0, like the 0 value that we're dealing with at the moment. This one's, again, this one's catching me out a little bit. So we have bits, we have our value. Bit is, oh wait, why have I got bit there? Does that matter? I don't think it does it? This is just each of these, or maybe this should be value. No. Oh, right, okay, this is just throwing me now. I feel like I'm just having a bit of a blonde moment, and I can say that because I am blonde. Right, so you can name item and index anything you want. I is a popular shortening of index. So index is going to be our, okay, my screen's frozen, fantastic. Is that because I'm, yeah, okay. Right, items, 0, item, and index. So bits, we've got value, which is represented our 0 here. We're saying bit, which is our, effectively our cursor, which we're going to be using to refer to each of these items. And then I, which we're going to call index for short. But here they've got a value I, like, let's store the bits of a binary number 1101 in little endian order, so least significant byte or bit first. So we have our bits and we have our value, which is going to be referring to each, actually, maybe we should do this. Oh wait, do we have to do the dot dot? Is that required? And then can I do value here and then index there? Is that right? Let's run that again. Capture value shadows a local variable from outer scope. Okay, so we can't use value. previous declaration here. Okay, so that's not right. That's fine. So my guess is that maybe we could use a value here. And like I said here, we can use a bit here and try that. Is that right? I think so. I think that is right. Okay. Okay, so let's see what I've done there. So, right, first of all, I think I left out the dot, which probably was what was causing the problem in the first place. I think that was it, yeah. Okay, I think that's a good place to leave it. So, right. Again, there's a lot more that I haven't touched on here, of course. You know, I haven't completed all the activities, but I'm happy to do another one of these videos again because again, I see the usefulness of this. It takes a little bit of time, of course, to get used to the syntax. As mentioned in previous exercise, for loops have gained additional flexibility since these early exercises were written. As we'll see in later exercises, the above syntax for capturing the index is part of a more general ability. Hang in there. Okay, that's a positive message to end it on. Right, I think that's a good place to end it because we've done 16 exercises now and I can obviously do more and more of these. You'll just have to let me know if you're enjoying them, but I'm enjoying them and it's a fun way to learn Zig. If you guys aren't enjoying them, then I guess it's something that I can do on my own to learn for the sake of it. Like you can see here, there's 115 exercises with 16 in, so there's a lot to go. But I mean, we could do, you know, a few half-hour episodes. We can work our way through all of these and maybe build a Zig project at the end of it. Who knows? If you guys got any questions, leave them in the comments below. If you guys have got any advice to any of the confusion that I've had around this language at first. But the one thing that I do want advice on, if anyone's made it this far, is what is up with that I/O interface. It's the one thing that I couldn't wrap my head around. It's the one thing that confused me. It's the one thing that I didn't enjoy touching on with this language. Had I done this in the first place, I think I would have had a very positive reaction to Zig. But yeah, let me know what you guys think, and I hope you enjoyed, and I look forward to seeing you guys in the next episode, as always. Thank you, and bye.